In our lab, we have physical PLC systems and an elevator model that can be controlled from the PLC system. In this film, I will show the physical elevator model and also a simulator in Codesys where we can test code for the elevator model without being in the lab. In the next film, I will show the physical equipment in the lab and how to connect the program for the simulator to the PLC system and the physical elevator model. This is a picture of the physical elevator model in the lab, where we have the elevator car, which can be moved up and down. We have buttons both in the staircase here and in the elevator car, but they are not in the elevator car, they are on the base plate here. Those buttons can be used for placing an order, for example. There are lamps in each button, which can be lit from the PLC program, both in the staircase and in the elevator car. On each floor, there are proximity sensors indicating when the elevator car is there. On the back here, on the elevator base plate, we have two buttons for up and down for moving the elevator manually up or down. They are not connected to the PLC system, only directly to the motor for manual movement. We will go back and take a look at the PLC system as well. The PLC system that we have in the lab is a Crevis NA9372 here. To that, we have connected input and output modules. They can be connected in any order and in any number, but for our systems we have used two digital input modules, two digital output modules, one analog input module and one analog output module. The digital input signals are coming from the system into the PLC system. The system, in our case, is the elevator, which means that the digital input signals are coming from the elevator to the PLC system. The digital output signals are sent from the PLC system to the elevator. For the elevator, we don't need the analog input and output modules. So we have buttons sending signals to the PLC, and also the proximity sensors sending signals to the PLC. They are digital inputs, and we have the lamps that are turned on or off from the PLC, and the motor drive also sent from the PLC, going up or going down. Those are digital output signals. To be able to test the program without being in the lab, we have a simulator. Here is the visualization of the simulated elevator model. We have the elevator car. It can be moved up or down here. We have buttons in the staircase and in the elevator car. They are not in the elevator car, but to the right here. And we have lamps, both in the staircase and in the elevator car. And we also have buttons for moving the elevator manually up and down. Those buttons should not be used in the program code. They are only there for manual movement of the elevator. I will show this simulator in Codesys. I have opened the elevator simulator in Codesys, and here I have the visualization of the elevator. And here we have the elevator car moving up and down in the staircase. We have a global variable list with the input and output signals that I had identified. We have the input signals, we have the buttons in the staircase and in the elevator car. We have the proximity sensors on each floor, and we have the output signals, all the lamps, both in the elevator car and in the staircase, and we have the signals for moving the elevator up and down. We also have a simulation file. The simulation file is there to mimic the movement of the physical elevator. Here it is a Codesys program, but in the physical system we will not use it because then we have a physical motor and we have all the sensors and so on. But we can take a look in the program anyway. It's an FPD code, and we can see that the global variable move up is used here, and then this variable position is what the visualization reads for this one. You can see that by clicking here and check the movement variable here, absolute movement, and then we can see that here I have the position from the simulation file. This program, the simulation file, it makes the visualization move, and it also gives the sensor input when the elevator comes close to the proximity sensor. But we should not change anything in this program. I will close it. Just to see how the simulator works, I will log in. Now when I have logged in, the image of the elevator disappeared. It needs us to start as well. I will do that. And here is my elevator. You can see that the elevator car is painted black now because it's at floor 1. I can press and hold the up button and the elevator moved. Now when it's not on the floor, it's gray. Now it's on floor 2 and it's black. I can press buttons. Nothing happens because there is no program reading the pressed buttons. But we can check the global variable list. I can drag it to here, then I can see it at the same time as my visualization. And here we can see that the elevator is on floor 2. I can write to the stair lamp 1 here, prepared value, control F7, and now the lamp is lit. I can push the button in the staircase on floor 1, and then the value here will become true. It is true as long as I hold the button, and it's false when I release the button. I can also try moving the elevator car up and down by using the move up and move down. We'll start by going up, Control F7, and it moves. If I try to go both up and down, when it gets a bit irritated and doesn't really know what to do, I will make move up, false again, and it goes down. And I can make move down, false, and it has stopped. We don't want to use the global variable list to move the elevator up and down or turning the lamps on or off. We want a program to do that automatically. I will log out and make a simple program that can move the elevator. I will make a new program by right-clicking on Application, Add Object, EOU. I will give it a name, Elevator Test, and I will use FBD code. I will just make a very simple code to see that we can have the elevator react on our buttons and moving through the program. I will start with RS latch. Drag an empty box and make that an RS. It can have the name RS0. I have to declare it, and there it is. I want my elevator to start moving down if car button 1 is pressed, and stop moving down if car button 4 is pressed. To make something happen here, I need to connect my move down variable here. Insert assignment and move down. At the same time, I would like to light up stair lamp 1. If I want to do something at the same time, I would like to have a branch. I can drag it from here and drop it here. That as well needs an assignment. Now I have my question marks and I can write something. Stair lamp 1. I want my elevator to move up as well, and I will use a new RS block. Here can be named RS1. I want my elevator to start moving up if stair button 4 is pressed, and stop moving up if stair button 1 is pressed. I need a variable here, move up, and I would like to have a branch here as well. I can make the branch from here by right-clicking, insert branch, right-click again, insert assignment. And I want to turn stair lamp 4 on if the elevator is moving up. Now I have a very simple program. It is not the best program because it allows my elevator to move both up and down at the same time, but I can use it just to try the simulator. As always, in order to run my program, it has to be in my main task. I will drag it here to main task. I do not want to remove simulation file from main task because simulation file is what actually makes the elevator move in the simulation. I will log in to try my program. I can log in with online change. Then the program will continue where it was. It had stair lamp 1 on, and the elevator was somewhere in between floor 1 and 2. I will log in. And we can see that the elevator is somewhere between floor 1 and 2, but this lamp is not lit. And that is because now my program is writing to the lamp and it's writing false. I will try this. I will try going up first by pressing staircase button number 4. My elevator is going up and we can see that the lamp is on. And we can stop going up by pressing staircase button number 1. To go down, I want to press elevator car button 1. And I can stop the movement by pressing elevator car button 4. If I try to go both up and down, we can see that both lamps are lit, but the elevator is stuck here. I will stop going up and it will be moving down. And I can stop moving down. This is not the behavior we would expect from an elevator, and of course the program needs to be modified to make this better. But I can see that my simulator works.